Before using many of the open source forensics tools explored in these lectures, of course, to come, you will need to ensure that your system is prepared to build said tools. So, as they are open source, the bulk of these tools are distributed primarily in source form. So, that is, you will need to generate the executable code yourself. In other cases, the tools will be scripts that require a specific interpreter to run. This lecture deals with the setup required to perform examinations with open source tools using Linux and Windows hosts. For each platform, we go through the several steps here. So let's start with building the software step. Because we're going to be working with the open source software, we're going to need to be able to take that source code and convert into usable form. Uh, so at a high level, this is known as building, and we will need to have one or more working build environments on the system we're planning to use open source applications on. This lecture sets up a generic development environment that can be used to build open source applications written in C and C++ languages and to build or install any libraries these lang applications require. Installing interpreters. Some of the open source applications we will be using are written in interpreted or scripting languages. So let me note that down. Interpreted, and actually let's proper interpreted and scripting languages. Actual programming languages, and these are the most famous three interpreted languages: Perl, Python, and Ruby. And Ruby. To run these programs, we will need the appropriate interpreter, and usually we will need some means to install prerequisite models that application rely on. So working with image files. So a key part of forensics examination is working with image files. Forensics copies of media. This is easier on some platforms, but it's necessary on all. If we can't open the container, we can't get the contents. An important part of the setting up an examination system is ensuring that you can access work with image file directly. While the forensics tools worked with in later lectures can access image files directly, having multiple means to access them is an effective means of verifying the operation of our tools. Having this capability also serves as a hedge in case our forensics tools fail to process a given image file properly. There are two general classes of image files. We will be working with raw image files and forensic containers. Let me take these as note here. There are two general image file types on computer forensics. So these are the raw images and forensic containers. Here. So raw image files are exactly what they sound like, a pure bit-for-bit copy of source media. So raw is the, actually write it down, bit for bit copy of evidence here, and forensic containers here they are special file formats designed with forensics use in mind. So these are the special files, special file formats for digital forensics applications. So you will see what forensics containers sounds like, because there are some extensions about it. So every forensics programs uses some forensics container for itself. So generally, these will contain equivalent data found in raw image, and will also contain checksum information or metadata about the container. In addition, for instance, container formats may allow for compression and encryption. So you can encrypt and compress your forensics containers, but in raw bit for bit copy evidence, it is not suggested way compress or encrypt by any means. So working with file systems. Finally, there will be times when we, as examiners, will need to interact with the file system contained in image files using native system functionality, but still in forensically sound manners. For example, to examine a ext4 file, we will need to use native system capabilities rather than forensics utility, simply because they are no open source forensics utility that can interpret ext for file system at this moment. So there may be uh, have there may be will some develop some X4 analysis programs in future, but at this time there is no programs for investigating X4 file system. So what's like using Linux as the forensic investigation host? Using Linux as the base is the most common way to set up an open source forensics platform. So in this course, we will be our supported use case. In these examples, we are using Ubuntu, as you can see here. So we will use Ubuntu in this course here. So, but if you have a different distribution, you prefer using Galerdy, it's entirely possible to do so. So we will use the Ubuntu Package Manager apt here. Actually, let's open the Ubuntu Package Manager is the apt here to install software throughout this course. However, none of the software we are installing is Ubuntu specific, and most of the packages we install should be available via the package manager in your distribution of your choice. So actually, we will get dive into Linux command line in later lectures. But for now, I want to briefly introduce your Linux terminal command line refresher. So ideally, you will come into this course with some Linux experience, right? If you don't have, don't worry about it. You will learn Linux in depth in next lectures. So if it's been a while or you are brand new, here's a fresh introduction of basic terminal commands you will need to use to navigate and work with files. So cd changes the directories. So cd, for example, cd for goes up the directory. So we was the home here, and ls lists the contents. Actually, ls lists the contents of our directories, so and files. So let's cd and os boxes here, and as you can see here, we have the files here. So we can use lsl command as well to show the dates of our files. and pwd will print the current directory you are in our case is the home OSBoxes. OSBoxes is the virtual machine download website, so you can use it if you don't want to download ISO file and then install it and then configure it. You can just go to osbox.com. This is an open source project and free, of course. So here, no thanks. As you can see here, osbox.org. So you can install Linux operating systems and distributions here. As you can see here, we have Android as well, Arch Linux, Fedora, OpenSUSE, Debian. You can, if you are using VirtualBox, there is a VirtualBox option as well. If you are using VMware, there is an option for that. So let's go to download page. Virtual machine, you can check VirtualBox images or VMware images. If you have high-end system, you can use virtual VMware here. By the way, just let you know, VMware using Java here. But you installing VMware, actually it will come with actual VirtualBox using Java. But if you're installing, you have to install Java as well with VirtualBox. So as you can see, we have CentOS here, Devuan here, Fedora here. There's a Kali here. We have Kali Linux. This is the just VMware image. Just that you can don't need installation or something. You just open it. So as you can see, let's select Ubuntu here. Ubuntu here. As you can see, Ubuntu. Download. Click on this link. And as you can see here, we can download, you can select the versions of Ubuntu here. So in my case, I think my version is 20.10. It's Gorilla here, as you can see, 20.10. Or you can use newer versions as well by just clicking the download and installing it, then opening in your VirtualBox. So I will close it here. As I said, pwd shows the directory, will print the current directory you are in case you get the home OSBoxes here. So cp will copy the file or will copy the directory and all items in the subdirectory. We will rename or move file. So you can use mv command as renaming files or removing files as well. Rm will delete files. Cat will dump the contents of a file to the screen. The pipe character is used to change the output from one command to the input of the next. So if you don't understand this, just wait until the next section of this course. You will learn in depth of Linux introduction. Actually, this will be the next in this course. There will be 4 or 3 hours Linux tutorial training here. So don't worry about it. You will learn Linux command line and Linux as well. So just skip this here, clear here. So how would the extracting software will be here in Linux? Actually, just brief introduction. You can use tar command to extract the software. So Linux source code is usually distributed in compressed archives known as tarbells. Tarbells here. To extract these, we will use the tar command along with a handful of flags. To extract tarbells with tgz, tgz or tar.gz here, extensions, gzipped, these are the gzipped tarbells. Use the command xzip and your file name that you want to extract. File name here. So skip this as well. So now we're coming to the installing our examination and build essential here for C++ programming here. So let's just sudo apt get install build essential here and enter your password here. This will download 172 megabytes of additional disk required here. So just click, just write E and enter. So as you can see here, we have an error here. Okay. It's missing. Actually, we will download build essentials in next lecture. We don't need it for now. So as successful execution to the configure script, we're going to make file here, make file. Let's install make file as well. Actually, we need to install sudo apt update. Here. So if you're getting these errors like me here, just copy this command here, sudo set. Just look at it. I will copy this in lecture description here, and the enter second command here with sudo here. Here, and now let's run the build essential here. And you run the sudo apt update here. So in this now we will use the old packages, old releases for Ubuntu here if you're getting some error like that. It's loading. I will stop the video. Our command is almost executed here. So now we can install the build essential here. Just sudo apt install build essential, and here, as you can see here, our build essential is installing now. I will pause video here. So as you can see here, our build essential tools is installed. As you can see here, we can run gcc here. So gcc is running version, as you can see here. So let's install make here. As you can see here, our make is installed as well. Yeah, like that. As you can see here. So in this lecture we will continue. So this was the part one of this lecture. It's almost 20 minutes here. So in next lecture we will continue this installing our computer forensics environment. Thank you for watching, and I'm waiting you in next lecture.